Hey everyone. So we're going to watch through the lesson 1 that we couldn't get through today in class. So here we're going to look at equations for the first time. So basically we just have to know what an equation is. It is simply a statement of equality between two expressions. So if I'm looking at this first exercise, I just want to figure out which one is not an equation. So out of my options here, the one that is not an equation is choice 3. Okay, one really easy way to tell is that out of these 4 options, number 3 does not have an equal sign. So think of equation as it has to have an equal sign because it should be two things that equal each other. So if you don't see an equal sign, it can't be an equation. Now, there's different types of equations. Okay, the first is a mathematically correct equation. So this statement right here in choice 1, that is mathematically correct. Okay, we know that because 3 plus 1 is 4, and 4 plus 0 is also 4. So that's mathematically correct. Okay. Now, 2 is an equation that we don't technically know if it's mathematically correct. We know that it's given as an equation, but we would go on to try to figure out and solve what x would have to be to make it mathematically correct. So that's only mathematically, that's dependent on something else right here. So we would have to test that. Now, it's what we definitely know is choice 4 is not mathematically correct. Okay, so you can also think of that first one as like a true statement, while 4 is a false statement. And that middle one in here, 2, well, that all depends on what x is. So if I'm considering that equation, 2x minus 8 equals 10 minus x. Again, we can't determine whether this equation is true or false. The reason why is because we don't know what x is. So we know it depends on the value of x. So now in part B, we can actually test this. We can see if x is equal to 5, will the equation be true? So we're going to take x equals 5 and plug it into anywhere that there was an x value. So anywhere that x was originally, I'm replugging in x as 5. And I'm going to solve using my order of operations. So 2 times 5 is 10, subtract 8. So 10 subtract 8 is 2. So the left side of our equation is 2. 10 minus 5 is the same as just dropping those parentheses. 10 minus 5 is 5. So this is not a mathematically true statement, so it's not equal to. So I put that slash. Now, technically above that, we didn't know if they were equal. I would go and put the question marks because we don't want to say that they're equal at any point because we just found out that it was not technically true. So we don't want to accidentally say that they are equal to each other. Now, if I'm still considering that same equation, now we have x equal to 6. So 2 times 6 we know is 12. Subtract 8 is 4. So I can leave my question marks in there. 10 minus 6. That is equal to 4, so that one's good. Okay, so for this equation, x equals 6 is known as the solution. Now in exercise 3, we have 6 different equations that we want to test to see if we have the solution. So what I want you to do is actually try to do this. So I want you to pause the video here and take a moment to solve each of these equations. Once you've done and solved and plugged into C, then hit play and we'll see how your work matched up to mine. Okay, welcome back. So I'm just going to run through how I would solve these ones. And you can check your work against mine, but we are plugging in 7 for x, (17) does equal 17, so x equals 7 would be a solution. So we can say, yes, it is a solution here. Now we have x is equal to 10. Remember your order of operation, so we are going to subtract that 10 minus 20 first. We get negative 10 divided by 5 is equal to negative 4. So remember, we are testing this, so I want to make sure to have those question marks in there. But we get negative 2 equal to negative 4. That is not true. So they are not equal to each other, so no, this is not a solution. C you could do in different ways. We could just be plugging in first, or you could distribute, but 2, we're going to have 4 plus 5 in those parentheses. We're testing to see if it's equal to 6, parentheses 4, subtract 1. So I could do the parentheses first. I would get 9 in there, which means 18 is the left side. I'm still testing here, so I'd have 6 times 3. And that does, in fact, equal 18. So we are good to go there. So this is yes again. Now in here, we're going to have negative 1 squared, subtract 1, equals 2 times negative 1 plus 2. I'm going to put that question mark over because we're testing to see if it's true. Negative 1 squared is a positive 1. Subtract 1, and we get that equal to 0. We're testing it on the other side, so we get negative 2 plus 2, and that does, in fact, equal 0. So we can say yes again. Okay, and then we have the two other ones, E and F. I'm going to have 3, and I'm plugging in 2 plus 2 all over 4. Subtract 1 is going to equal 5. So remember parentheses. 3 times 4 is 12. Oops, I'm forgetting to put my question mark because we're testing to see if that's true. 12 divided by 4 is 3. Subtract 1 is equal to 5. And we end up with 2 not equal to 5. So no, this one does not work for us. Last one. We're plugging in 8. Okay, so we're testing if it's true, so I'm going to give it that question mark. 3/4 times 8 is going to be 6. Subtract 1, we get 5. We're seeing if it's still equal. So 1/2 times 8 is 4 plus 9. 4 plus 9 is 13. Oops. Sorry about that. I just noticed that it's supposed to be a negative 1/2. Missed that negative. So I'm going to change that to a negative 4 plus 9. Negative 4 plus 9 is, in fact, 5. So that does check out. Now in exercise number 4, we have Scooby-Doo is checking to see if x equals 7 was a solution to the equation 4x minus 3 equals 2x plus 11. He concluded that it was not a solution based on his work. Was he correct? Well, when we're looking through here, so we have Scooby has 4x minus 3 equal to 2x plus 11. He plugged in the 7 for both places of x, so that part's good. But notice here, Scooby subtracted and added to get this 18 to get this 4. That's not the correct method by PEMDAS, right? Our order of operations. So technically, before we do that, multiplication comes before addition and subtraction, right? So what we would have done is if we had 4 times 7 minus 3 equal to 2 times 7 plus 11, well, I would have had 28 subtract 3, which would have equaled 25. And then 14 plus 11, which also equals 25. So, unfortunately, Scooby-Doo was not correct. So, last one, we have Fred and Daphne were trying to determine the solution of the equation x squared minus 36 equals 0. Now, Fred determined that x equals 6 was the solution of the equation, and Daphne determined that the solution of the equation was x equals negative 6. We're going to verify that both of these two were correct. So let's look at Fred. So we're going to plug in 6. So 36 subtract 36 is equal to 0. So 0 equals 0. So he's correct. And then Daphne. So remember, negative 6 squared really gets us a positive 36. So I've just verified that both are correct. Now it is an explain question. So we want to be able to explain using words why this makes sense. Well, think about it. The two of them both plugged in a number and got an answer. Remember, a negative 6 squared is really just going to get us that positive number. Some equations have more than one solution. So that's what we're going to write. And squaring a negative number gets a positive solution. Okay, guys, so that's just our intro to equations. All you have to do is complete these notes for homework tonight, and then we will practice some more in class tomorrow. Thank you for watching, guys. Appreciate it.